Welcome to Lesson 4. In this lesson, we are going to look at variables in greater depth. We're going to learn about primitive types and use them in variables. We are going to look at numeric variables in greater detail, character variables in greater detail. You are going to learn how to convert numeric values from string values using wrapper classes. And we are going to learn about constructors as setters, access modifiers, the final keyword, and formatting the double to 2 decimal places. After that, we are going to create a motorized vehicle telemetry simulator class. And when we have finished this lesson, as a practical project, we are going to build the vehicle logbook class using POJOs, like we did with the same design pattern in the previous lesson. The concept of variables comes from mathematics. The ancient Greeks used letters to represent numerical values. Pythagoras gave us pi and the formula to calculate the circumference of a circle. He also gave us a formula for calculating the hypotenuse based on the values of the adjacent and the opposite in a right-angled triangle. At school, we learned to use x and y as variables in algebra. Today, we don't like to use x and y as variable names. We want to use words that describe what the value represents. So, a variable name like the following would be acceptable: unit price, cost price, total profit, net profit, voltage current. From these variable names, you know exactly what they represent. Java gives us a whole lot of primitive types, which we can categorize into 4 categories: numeric values, character values, booleans, and I've added in this slide string, which is not a primitive type, but we seem to use it like a primitive type. And we've been using strings for so long that these types here are basically what we use when we declare our variables. Now, a byte allows me to have an 8-bit number. These usually store characters. A short gives me an integer with a number from 32,000. So shorts are not very useful in the Java language. I have yet to find a place in my 20 years of coding where I've used a short. I cannot remember using a short. Ints, however, these represent numbers up to 2 billion. You see, this is a 2 billion, 2,147 billion. So for most of the numbers where the number is smaller than 2 billion, smaller than these values here, we would use an int. There is an exception though. When we are working with database transactions and with the keys in a database, we want to be able to have the number of records that a database can hold not be limited to 2 billion, because if I have 4 gigabytes of information and I want to store that into a database, or I want to read 4 gigabytes of data, then this number is not big enough. So in that case, we would use longs. And as you can see, these are fantastically large numbers. I've yet to remember if I ever used a float in my Java coding. Floats and doubles are floating point numbers. Floating point numbers are numbers with a decimal point inside them. In other words, it's a number with a fraction. So as we mentioned earlier, these would be numbers that would store temperature or money, dollars, euros, pounds. And we would not use a float, we would use a double, so that we are not limited by billions, but we can work with trillions of dollars. Secondly, the double gives me 15 decimal places of precision for accuracy, if I'm trying to calculate pi to 15 decimal places, I definitely would use a double and not a float, because floats only give me numbers with 6 to 7 decimal places. Now, character we've mentioned before, some developers call it a char. I prefer to call it character. So character variable. And we mentioned that you can store characters in them with single quotes, or you could store ASCII values as numbers. Now, the fourth type of variable, the Boolean. Booleans are used to store logic. In other words, this is true, this is false. So the operation ran successfully. The transaction failed. That's where we use Booleans. And a Boolean stores a single bit. In some databases, they store Booleans as an integer, but of size 1 bit. And then I added string here, although it's not a primitive type. What I have on this page is all the types that we declare our variables, and it was useful to put string on this page. The integer types we use most of the time are int and long, as I mentioned before. And you can see that the int stores 4 bytes, so it's a 32-bit number. So it's a reasonably high precision number. As we mentioned before, this can go up to 2 billion. And the long is a 64-bit number. So it stores 8 bytes of memory space. And as you can see here, these are fantastically large numbers. As I mentioned earlier when we were talking about floating points, I have yet to remember ever using float. Float, as I mentioned earlier, has a limitation of 6 to 7 decimal places, and they're not very big numbers. So you would land up, if you were doing scientific calculations, to use a double. These are 64-bit numbers, and they store 8 bytes of memory. So the double and the long have that in common, that they are the same precision. 8 bytes of memory and 64-bit numbers. And we mentioned character before. I needed to have the slide, so sometimes we want to repeat things to get the message across. So there were 2 ways of storing a value to the character. You could store it this way, where you have a character inside single quotes, or you could look up the ASCII value of that, which is 65, and you could store 65, and that would also store an uppercase A. And then we mentioned strings as text variables. Now, there are 2 ways to define a string, or to declare a string variable. This way is the primitive way of declaring it, where you say string s2 equals, and you assign it a value that could be inside double quotes. The second way to declare it is to use its constructor. We know that string is a class, and therefore as a class it has a constructor. So we can call its constructor and pass the value into the constructor. Now you may say to me, why do I need 2 different ways to declare a string? When you declare a string this way, the string is stored on the stack. The stack is a temporary memory that is used during a method operation and released. If you declare a string this way, it goes into a different memory. Java also has a memory called the heap, which is a permanent memory. And any object that's instantiated, in other words, we called its constructor, that object, so S1, gets stored in the heap. Now, sometimes we want to join 2 or more string variables or string values to create a long value. We talk about concatenation. So here we can say S3 equals S1 plus S2. And whatever value this has plus whatever value this has becomes a new string and gets stored in S3. We can also use a special operator, the plus equals operator, to do the same thing. Now, here we declared the variable S3 equals S1, and then we say S3 plus equals S2. So here we had a string with a value that was inside S1, And now we want to add to that value the value that's inside S2. So it creates a new string, and then it replaces the value inside this string with a new string. And that also happens here. It replaces, here we just declared it, but here we concatenated it and we are replacing the value inside this. So this concatenation can be dangerous. When I was at IBM 22 years ago, I was a young developer at IBM. I remember the senior developers warning us never to concatenate strings in a server or banking application because you run the risk of creating memory leaks. And memory leaks can be very destructive. Another thing that we need to be aware of is if you try to email Java code, Microsoft Word and Microsoft Excel converts this double quote into a pretty looking Microsoft double quote. And when you take that code and you try to compile it, you get errors. Always put your code inside text files and email text files. Never email Word documents or email text inside an email. Put it in a text file. We have learned how to create string values from numeric values in the previous slide. Now we need to do the opposite. Now we need to take a string and convert it to a numeric value. And to do that, Java gives us wrapper classes, the integer, the double, and the long. And these wrapper classes have got their own parse methods. So I can have a variable string potatoes equals 4, and that's a string. And when I use the parse int method of the integer wrapper class, it will turn that into an int. So here I can declare a variable int number of potatoes, and I'm able to convert potatoes, that's a string, into number of potatoes, that's an int. And likewise, Java also gives us the double wrapper class, which its parse method will return a double. Notice that these wrapper classes, they are classes, and the names is declared with the uppercase first letter. These are actual classes, and we are using static methods in these classes. We're going to learn about static methods in this lesson. So the double has a static method called parse double, and because it has a static method, we can call it directly like here and like that. So that means that we don't have to instantiate wrapper classes to use them. And then the last one is the long. What long allows us to do is to take a numeric value in a string and convert it into a primitive long type. So I can declare a variable of primitive type web page hints and then give it a string value which it will convert through the parser. There is a problem with using wrapper classes, and that is if you have invalid strings, you're going to crash your code. Let me explain. Here I've declared a string cost, but notice that I've put the letter A inside there. This is not a number. And if I call the parse double method and I pass it this value here, this is going to crash my code. In actual fact, the exception that Java is going to throw, this is the error message I'm going to get. It's going to throw a number format. It's going to throw a number format exception. So the way we handle this is to put the wrapper class parse method inside a catch block. You see, here is the try catch block. So what we do is in the try, we try to convert the string value into a double. We try to do that, and if this value is valid, the happy case, it will convert it. If the value is invalid, it's going to get an exception, but it's not going to crash my code because I catch the exception here. And because I catch the exception here, I'm able to then print a message to the user. I can say, your string is invalid. And then I can say get message. So here I'm able to display that. I've now created a class called variable examples. I'm going to open it up. So I've opened this class Now, I have provided you with the source code, but personally, I would prefer if you don't cheat and if you do the exercise with me. So create a class called variable example. The file name is variableexample.java. Copy up to here. Pause the video now. Having done that, copy the rest of the code, save the file, and now let's go and compile it. You shouldn't get any errors. Now let's run this code. And I'm going to open it up in the text editor so that we can look at the code as we ran it. So in the top here we have sum equals sum of x and y is 3. Let's have a look at the code. We declared a variable x1 and 3 and we added. This is very simple. It's not what these 3 lines here are doing that I'm interested in. It's what this line here is doing is what I'm interested in. So I've taken the value of this variable here. There it is, and I've concatenated it with a string, and I'm able to display that there when I did the system out print line. And then here I did a similar one, the number of transactions, the number of successful transactions, and if I subtract these two, I will get the number of failed transactions there. And then here I displayed the number of failed transactions, which is what I'm interested in here. I'm only interested in this line here. So I've taken a string and I've concatenated it, the value of a variable, and that's what we got in the display. And then the same with the price. I have a price and a markup, and I calculated that my price is cost price times markup, and then I created the price label is dollars plus that. And now what I'm interested in is displaying what that line does, and that's the value. I just want to point out something. Lazy developers will use this code like that to convert a variable into a string. Just be careful when doing that. There is another way of doing that. We have looked at the wrapper classes in the previous slide. I would look at using wrapper classes. They have a toString method. That's the preferred way of converting numeric values to string. Use the wrapper class. And then the last one here was Joe Soap. And all I'm interested in here is I've declared these values. These are strings, and I've concatenated them. And I will now have full name and the value of the variable full name. And you can see that I've stored in the full name, I've stored name, which is Joe. I added the space, and then I added the surname. So that's how I managed to get Joe and Soap separated with a space. That's how I did it. But what I'm interested is this. I've got a variable of mixed type here, and I'm adding it to a variable that's of a type that's of string. And then when I do that, it takes the result as a string. And that's what I got. Right, let's continue with the lesson. There comes a time when you want to do financial transactions or financial applications or applications that have tight security. And creating POJOs to store transactions in can be dangerous. If you have setters, a hacker can get access to the code, and he can go and modify the account number with his and the account and the customer name with his, and steal money from the bank by diverting the transactions to his account. So one way to prevent that is to have certain fields that you never expose through setter methods. And the way we do that is by using a constructor, and we pass the constructor parameters. Now, what we also do is we make the default constructor private. So that means that the hacker can't go and instantiate the object and then, having instantiated the object, set the values, because we don't give access to the default constructor. These only get set during the construction of this class in the default constructor as parameters. And what this does, it makes the instance almost behave like a read-only type object. If you put all your fields in there, then you got a read-only object. Here is a place where I want to use that. If I've got telemetry for the Mars rover, and we're going to write a program in this lesson to simulate this. Now, what I want here is I want to prevent a hacker from changing these lines here. So this is what would happen if I didn't use those fields inside my constructor. So the second constructor and made the default constructor private. A hacker could break in and change my telemetry. Of course, this would be embarrassing for our space friends. Access modifiers are very important in Java, and use them carefully. Don't make every method and every variable in your class public. In actual fact, when we talk about encapsulation, we make the variable fields, or the field variables, I should say, we make the field variables private so that nobody can change them or have direct access to them. And we can declare our methods as public, certain methods as private, and we can have certain methods that we can declare as protected. And why we would like to do that is I'm going to create a superclass called vehicle, and then I'm going to create a child class called Mars rover. And the Mars rover class is going to inherit certain fields and methods from the superclass. Anything that's not private, it will inherit. But I may also want to prevent certain variables and certain methods from being accessed outside the child class. So then I would declare those methods as protected. So only the child class can see the protected methods. They will be private outside the child class. We're going to see this when we build up our Mars rover project. You may have noticed when you declare constants in Java, we use the final. So we declare variables as final. You can also declare methods as final. So if I have a superclass, the vehicle superclass, I may have a certain method in there that I write. And to prevent people from modifying my method's behavior, I can declare that method as final. So any child class that uses my final method cannot change the method. You will find that you can override methods of the superclass in the child class, but you cannot override a final method. So that's where final is used in methods. And then sometimes I may have written a financial banking class that I want people to use, but I want to prevent people from being able to modify my code and even the behavior. The entire class can be declared as final public final class. And once I've done that, you can now have a problem. You can instantiate that class, but you can't override methods. So it's as good as you can't make child classes from that, because you make a child class with the intention to override methods. So that can be used in banking as a security feature. We get double values, and when we want to print them, you may find that it prints it with 1 decimal point or 1 decimal digit. If you do system out println and then the double variable. this is the way that you can control how many decimal points you want this to be formatted. So what we are doing is we are taking the double variable speed, and it's 123.456 kilometers. You see that? Or miles per hour, whatever you want to call it. But that's the value. Look, there's 3 decimal points. And I may want to format it to have 2 decimal places. So the string class gives us a format method. All you need to do is just paste this code like that. That tells the string class that I want to have 2 decimal places. .2f gives me 2 decimal places, and then you pass it this value here. So this almost looks like that the string is a wrapper class, and this looks almost like a parser method, but it's a special method. And you will notice that this is a static method because string is declared here in uppercase, and we are not calling a variable, a string variable, but we are calling the static method of the string class here. And then that's the value that it's going to put in that string, and then when I print it, I get that. Now notice 0.456. I got 0.46. So what did it do? It rounded this up to the next decimal point, and this rounds up to a 6. That's what I got. And we can format, in the previous slide, we formatted doubles to 2 decimal places. But we also want to be able to format the date. And we need to do that because there's a different format for the American date. There's a different format for the British date, and there's a different format for the international ISO standard date. And what you are seeing here is the format for the international ISO date. So what we are the way this works is we create a simple date format. We use simple date format, and we declare it as a static. You see, this is a final, and this is a format. You can create different formats. So this could have been ISO. You can create another format for British and another format for USA date. Now, all you need to do is take these years and pass them after the D's, replace the dashes with forward slashes, and then you will have converted this format into American date. If you want to make it British date, then you put the DD, you reverse this, you put DD in the front, /MM//YYY. Now, there are 4 Y's because we are displaying the date as the year. We are displaying the year as a 4-digit figure. And then there are 2 uppercase M's. We are displaying the month as a 2-digit number. And the same with the day. There's 2 DDs. We are displaying the date as a 2-digit number. And then here's hours, minutes, and seconds. So notice minutes is lowercase m, month is uppercase M. Using the simple date format in this line here, we've now specified the format as I mentioned. So having this as a constant, when I want to take the current time, so I will say timestamp is new timestamp, and I pass it the system.current time in milliseconds. So this is going to take the time in your clock on your computer, the time in the clock in milliseconds. And it's basically milliseconds from a certain year. I think it's 1970. Don't quote me, but it is a certain year. From that time until now, this point in time now. And it'll take the number of milliseconds, and that's a value. And that value will be a long. And what we are doing here is we're converting that value into a timestamp. So we now have a timestamp, and this variable timestamp is now declared. So this will have the current time. However, that date that we see here, it depends on how the server is set. I've worked with servers where the system operators never set them to the correct time zone, so you'll end up with dates that you can't use. And this is the only way that you can control the format. So having got the timestamp, we now use this SDF or this format object to format the timestamp, and then that returns us the time, and it returns us the date and time. This string is replaced with numbers. So that's how this works. Now let's go and look at the vehicle class, because we are using all this that we have learned in this lesson in there. You will see that we have a couple of classes here. We have the Mars rover, we have the motor car, and then we have a motorized vehicle, and then we have a test. So let's open up the motorized vehicle class. You can be lazy. I have provided the source code, but I would appreciate if you do this with me. So create a class called motorized vehicle. The file name will be motorizedvehicle.java. In actual fact, if you type that command there, notepad motorized vehicle Java, you'll get an empty file. Copy the code up to this line. Pause the video now. Now copy the code up to here. Pause the video now. Now copy the code up to here. Pause the video now. Now copy the code up to here. Pause the video now. Now copy the code up to here. Pause the video now. Now copy the rest of the code. I assume you've done that. I'm going to explain this before I compile this class. Notice this class does not have a main method, so we can't run it. You may remember in the previous slide we mentioned how we set up the date format. So that's how we set it up for the international ISO. Remember when we're working in space and in other applications, we are not going to use British or American date format. We want to use international formats so that whether scientists in Europe or scientists in America are working with the same thing, they don't cause problems. There was a reason for one of the space shuttles having a disaster where people died, because the calculations were done in metric and the same values were used as American values instead of metric values, and that caused problems. Enough of that, but just to mention why in certain cases we want to use international standards and not local standards. I am creating a class, motorized vehicle, and this is basically going to hold the telemetry. So in one case, I'm going to use this code in my Mars rover, and I want to be able to transmit the telemetry. So what the rover transmits from the planet Mars to Earth, that telemetry is what I want to simulate in this program. So I've declared these fields here. You will see that there's a vehicle type and a vehicle manufacturer and a model, and you'll notice that you'll notice my constructor is private. The default constructor is private. As I mentioned earlier, And I have this constructor where I preset those values so that those three things that you saw in the telemetry that the hacker could change cannot be changed. However, there's certain methods that I have created for steering the vehicle. So I've created a method called start engine, stop engine, accelerate for so many seconds, decelerate for so many seconds, turn left for an angle of so many degrees, turn right for an angle of so many degrees, go forward for so many minutes, and then I've created a variable called get status. So you can see there are no, and then I've only created 3 setters. And these 3 setters are used when I want to use this vehicle as a Mars rover. If I'm going forward for so many minutes, it's not going to reach a speed of 200 kilometers per hour. However, when I use the same code to simulate the telemetry of a Lamborghini or even a Ferrari running in the Formula One, then after a minute, we will reach a speed of about 200 kilometers per hour. So in order to be able to compensate for the type of vehicle, that's why I've created these special methods. So there's only 2, the increase factor and the decrease factor. Other than that, there were no setters and getters. And the get status is what's going to display the telemetry. You may remember seeing a screen like this on the slide. Now, this is what we call the superclass. I'm going to look at the Mars rover. So the Mars rover is a child class of the motorized vehicle. So you see, what we are doing now is we are talking about inheritance. We've created a superclass, and here I've created a child class. The Mars rover is a child class of the parent class. They also refer to a superclass as a parent class. And just like I got my father's nose, my mother's eyes, and my grandfather's Italian accent. So likewise, in Java, you can have a child class that inherits things from the parent. Now, in C++, you can inherit from multiple classes. So I am a C++ animal. I've inherited from my mother, from my father, and from my grandfather. But in Java, we do not allow that. We only allow one superclass. There's a reason for that. And this is the way we declare it. So that's the way we declare that the Mars rover extends the motorized vehicle class, the parent class. And because I extend that class, notice that I only have 2 methods in here and I have a constructor. So what's happening here is it's those 2 things, the speed increase factor and the speed decrease factor. These are the only 2 methods that I override. So whatever was in the superclass, by overriding it, I change the code. Now, there are some rules you need to remember. When I have a superclass, which I have here, in my constructor, you see a method with the same name as a class is called a constructor. So in my constructor, I've got to call the superclass. Otherwise, I will not be able to access the code that's inside the superclass when this program runs. So Java gives us a reserved word called super. And then all I'm doing now is I say super with brackets. So I'm basically calling the constructor of the superclass. And you may remember in the superclass, I passed it a value, rover, and manufacturer and model. And these are the values that, notice I called the first rover. I could have called it Mars rover. In fact, let's do that, Mars rover, save. So that's what this is doing here in my constructor. I called a superclass constructor. Now, because I overrode this method and I don't want to rewrite all the code for this method, I am now picking up what I'm doing here is I'm writing a message. So when this constructor gets called, it's going to say speed increase factor in Mars rover class set to that. and not the superclasses method. It's going to display this. But now here I'm saying super and I'm calling the same method. And I'm passing this value here to the superclass. But to prove that I actually called this code and not the superclass directly, that's what this line of code is for. It's part of explaining how this works. And then the same for the set speed increase, the set speed decrease, same thing. So now you guys create a class called Mars Rover. The file name is marsrover.java. Pause the video now. I assume you have done that. Save your file. I'm now creating another child class of the motorized vehicle, and this is called the motor car. The rest of the code is identical to the previous slide, but why I'm doing this is because I want to be able to say that I've set the speed increase factor in the motor car class, or I set the speed decrease factor in the motor car class. So this class will inherit all the code that's inside the motorized vehicle. In other words, the parent class or the super class. So this is another child class, the motor car. Create a class called motor car, file name motorcar.java. Copy this code as is now. I assume that you have done that. Now let's close this. Now in Java, when you create a class or a superclass, you always want to create a unit test. So let's do that. Here I have a class called vehicle test. Let's make this thing full screen. Copy up to, well, you know what, don't take that part on the top. Create a class called vehicle test. The file name is vehicletest.java. Pause the video, copy this whole code as is. I assume you have done that. Now let me explain what's going on here. I'm printing a line here that says motorized vehicle telemetry demo. Now notice that I'm creating a motorized vehicle Lamborghini. Now watch this. This is the superclass. You see, I'm creating a variable of type the superclass. Motorized vehicle was the superclass. But I say new motor car. This is the child class. So Lamborghini equals new, the child class. And here I put Lamborghini and the Aventador Roadster. So what I have in here is going to be set in the child class, which will set it in the instance of the superclass. Remember, the child classes constructor calls the superclasses constructor. So I now have a Lamborghini variable, but this Lamborghini variable is actually of motorcar, and because motorcar is a child of the motorized vehicle, I'm able to declare it this way. Otherwise, I would have had to say motorcar Lamborghini, but now I said motorized vehicle Lamborghini. So now let's go and see, here's how we use it. For the Lamborghini, we need a very high speed increase factor. So that's 37.5. So that's the amount of kilometers per second that the speed increases by. And for braking, this is the kilometers per second, kilometers per hour per second, that the speed decreases when the driver hits the brakes. So what I am doing here is I say start engine, accelerate for 5 seconds, turn right, go forward, decelerate, accelerate, decelerate, and stop engine. Now each of these methods calls the status method. Remember, I declared my status method, and each of these methods calls the status method, so it will display the status. We'll look at that in a minute. I just want to, so here I did the Lamborghini, and then I said stop engine. So we should see all the statuses as this thing runs. Now let's look at the Mars rover. The same thing. The superclass was motorized vehicle. I declared a variable called Mars rover, and here I called a class called Mars rover. I could have made this opportunity. Instead of making this Mars rover, I could have made this opportunity. I don't want to do it now, but if I had done this and called this opportunity, it would have been better. Then all of these would be opportunity. And you can see there I called the Mars rover class, which was the child of the motorized vehicle class. I called its constructor and I gave it NASA, Mars rover, and opportunity, which is what we want to see in the telemetry. And because I used the constructor here, no hacker can change that. So likewise, notice now here I had a 37.5 speed increase factor. Here it's 1.5. So this vehicle goes very slow, but my speed decrease factor is very fast. I want this thing to stop quickly. And I pass different values to the parameters here. It's just to give me realistic telemetry. So here I accelerated for 12 seconds. Whereas with the Lamborghini, I only accelerated for 5 seconds. Here I went forward for 20 seconds. Now when I go forward, the speed doesn't increase, but it consumes fuel, so the fuel will decrease. Now there's one thing I missed in the simulation of the Mars rover, and that is that my engine is consuming fuel. I should have changed the units and made it battery voltage, and then the battery voltage would decrease as the vehicle moved forward. But doesn't matter, the concept is the same. So let's close this class. I want to go back to one of the previous ones, the super class. Now you'll see that when I call the steering methods, go start engine, stop engine, accelerate, you will see that I called the get status. Every time I did something to the vehicle, whether I made it turn or go forward, I called the get status. And again the get status. This was for accelerate, this was for decelerate, and I called the get status. So it will print the status as telemetry every time you do call one of these methods. So when we went to in the test class, so when we said start the engine, accelerate, turn right, it will actually display the status. And the code that I used for my simulator, the actual super class, it took a little bit of trial and error to come up with something that would be realistic. So now I need to compile all these classes. The acid test. We need to start from the superclass. So this is the motorized. Okay, that compiled. Then we need to compile the motor car. Motor car with the lowercase c. Java. That compiled. Now we need to compile the Mars rover. The Mars rover. The Mars rover compiled, and now we want the motor car. Right, that compiled, and now we want to compile our unit test. And that compiled. Now the only thing we can run here is the unit test. Now let's look at this telemetry. So it printed motorized vehicle telemetry demo, and now it's printing the telemetry for the Lamborghini, and it's displaying the preset values that I have used for this simulation. And you will notice here I have the Lamborghini Aventador SVJ Roadster. That is the name that was passed through the constructor, and then engine started. That was what I did. So I called the start method. Then notice that my fuel was 45.5 liters. My engine revs went up to 1,200 revs, and my temperature was 25 degrees centigrade. Then I accelerated for 5 seconds. This increased my engine revs. It also increased my temperature. Notice that my fuel went down a little bit. My fuel went down. And my speed, I was 0. And now I'm running at 187 kilometers per hour after 5 seconds. This might not be accurate, but you can always play with these figures here if you want to make it accurate. I'm just proving a concept. If you have such a requirement, now you have the code. You can modify it to your requirement. Then I turned right. Turning right will be immediate, so there should be no change in the fuel. There should be no change in the revs, and there should be no change in the speed. And then I drove forward for 20 minutes. Now, drove forward, I maintained the same speed, so I maintained that speed. Now notice, and my RPM remained the same, but I wasn't accelerating, so I maintained the same temperature. But notice that my fuel dropped from 45 liters to 32 liters. And then I decelerated for 3 seconds, so the only thing that should happen here is my speed should have come down. It did. Then I accelerated for 2 seconds, so my speed should have gone up. I decelerated, and then I stopped the engine. Now when I stopped the engine, my speed would go to 0 and my revs would go to 0. The temperature would be what it was before I stopped the engine. And the fuel is also what it was when I stopped the engine. And this was realistic because I came down to a very slow speed when I decelerated, so I was able to then stop. Now here is the telemetry for the Mars rover. Transmitting NASA Mars rover opportunity telemetry. And these were the parameters or the settings for the simulation. I'm not going to go through the values. You run this on your side and you should see the values. Let's just look at 1 or 2 of them. So I'm trying to see how realistic I made this. So I accelerated for 12 seconds and my speed only went up to 80 kilometers per hour. And I drew very little fuel. You see that? 0.01 of a liter. And then here, I turned right, so my direction changed. Look here, I have a variable, my direction is 0. So if you go and look on the compass, I'm pointing north. I'm still pointing north. Now here, I turned right 15 degrees. So now my direction is on the compass. I went forward. I decelerated. I went from 18 kilometers per hour to 10. So this is very realistic. I didn't make any change. So you have the methods there now. You can go and you can turn this into a game if you want, because take the code that's in this class. Let's actually open it up, Notepad. So you can take this code that's in this method here, and you can write your own game. And then you can put buttons on the, or you can give the user a command that says type A to turn left, F to turn right, X to decelerate, E to accelerate, and X to turn off the engine, and O to start the engine, or S to start the engine, something like that. And then every time the user does something, you can display the telemetry. So you can turn this into a game. And that was it. Thank you for looking at this lesson. I hope you enjoyed it. Please click the like button and also subscribe to this channel to help this channel grow. And also have a look in the comments and click on the show more link so that you can see what other videos we have in this series of training courses. Thank you for that.